There are cheap alternatives. Biofuel is a cheap alternative. In the past, we've done it from sugarcane. In fact, here in the Philippines, the San Carlos Bioenergy company actually signed with Petron to provide all of their ethanol, if I'm not mistaken, signed a couple of weeks ago with Petron to supply their bioethanol needs. We're also doing starch through corn, wheat, grain, rice, potatoes. And when I talk about cellulosic ethanol, again, we're looking at corn stover or switchgrass, wheat stalks, or sweet sorghum. And you're going to need the pre-treatment for that, the enzymes to make sugars, and the fermentation enzymes to make that into ethanol. Because it's a suboptimal process. This is what we do when we produce ethanol. We cannot pipe ethanol because it's very soluble. So usually ethanol is transported in trucks, which hopefully would be using ethanol in its gas tank, but we'll see. So that's also the complaint of organizations like Greenpeace. It's not really a clean fuel. Now, if you ask the biotechnologists, it's not a clean fuel. We never said it was, but it's a cleaner fuel. What the industry counts on is that it's going to make their gas bills cheaper. So cellulosic ethanol is going to have a very nice energy profile or environmental profile because we use a lot of forest biomass or agricultural biomass from residues and wastes. And only about 9% from the actual grains. Jatropha, which is being planted in Tawi-Tawi, for example, in this country, we have a problem as scientists about Jatropha. Primarily, that we have no actual research work done on our species of Jatropha. It would be fine if we were in India. They've done a lot of work on that. But also, Jatropha used to be used as an insecticide. We have no idea if you combust the oil of Jatropha, if that's going to be poisonous. I don't think so, because a lot of people used to just get the Jatropha seed and light it up and use it as torches in that area. So for fiestas and everything. I don't think so. But we don't know what would happen if we grew a large amount of Jatropha on land, and if there's going to be a problem of runoffs and so on and so forth. So cellulosic ethanol is going to grow. The demand for it is definitely going to grow because of the food for fuel controversy. In the Philippines, this is from the estimates of the Department of Energy, we are going to need in 2008, we're going to be using 32 million barrels of gasoline. According to our Biofuels Act, at 10% substitution, we're going to be needing 800 million liters, and the daily demand for ethanol will be at 2.2 million liters. We cannot continue to produce ethanol from crops, primarily because we are an archipelago. We don't have enough land. And if we're going to use all of our land to produce corn, what about people like Engineer Manayato who want to plant stuff for the nutraceutical and cosmeceutical businesses? We have scarce, and the greening of consumers. We project that the world plastic consumption is going to increase to about 258 million tons in 2010. Of that, the degradable plastics are going to grow 12% annually to 335 million pounds of plastic consumed, valued at $480 million. And conservatively, bioplastics could conservatively capture 4.8% of that market. There are several types of major degradable biopolymers. PHA is polyhydroxyalkanoate, and that's made from a bacterium called Ralstonia eutropha. That is the name of the microorganism. PHB, by the way, is a type of PHA. So basically, it makes the plastic and secretes it. They store it inside. It's about 85% of their cell weight. And there are companies that already do this. Metabolics, Mitsubishi has a lab doing this. Kaneka and Biomer. PLA is polylactic acid. This is starch which is processed and fermented to produce dextrose and lactic acid, and then you just polymerize that, and that's polylactic acid. Sorry, that's a typo. Cargill has been doing this. They're not only making the plastics, they also have fibers from that, and they're making fabrics, which I'll talk about later, as well as Toyota. Starch-based plastics are also a big group of that. And so there are several types of polymers. 8% is PHA, which I talked about. Mostly they're starch-based because that's the easiest to produce, if I'm not mistaken. The others, the 39%, they're blends of conventional plastic with PHA or lignin and conventional plastics, that sort of thing. They're just blends. The drawback of that is that bioplastics account for less than 1% of the consumption, because if you compare the prices of PLA with polystyrene, which is its closest in, I would say, characteristics, it's incredibly expensive. I mean, 1 pound of polystyrene costs about 65 to 85 cents per pound, and polylactic acid costs $1.75 to $3.75 per pound. So it's not cost competitive. Also, there are certain limitations because they're not plastics talaga. I mean, they're starch products. The starch products are very sensitive to humidity, so they're not going to be good in the Philippines. PHB is brittle, so it limits the number of applications that you can use it for. And you have to know the regulatory mechanisms in plants, because it's not what most companies are doing is they're making the plants be their factories, not just the algae but the plants. But if you don't really know how the plants work, you get a lot of impurities and problems with the biopolymer.